In today's class, we are going to discuss the chapter number 16, that is probability. So, you may heard the name probability. So, just I'll recall. So, just don't think about maths. Just normal days, we may speak like probably today may be rains. Like that we may speak, or we may call like we may think that probably tomorrow I am going to Bangalore. Like this we will think. So the probability, whatever will in normal English, what is the meaning is there, the same meaning will gives us in the mathematics also. So what is probability then? So probability, what is probability? That all we discussed in the 9th as well as 10th class. In the 8th class we discussed in the topic data handling. In there also we discussed the chances. We just introduced, that is the basic. It means in the 8th, 9th, 10th we discussed all this probability, is it? So just I'll recall the things and I'll let you know what is the difference between studying there in the earlier classes and what we are going to study in this class 11th. Clear? And remember my dear students, even we will study this topic in the class 12th also. That much important this topic is. Clear? So what is probability then? Then we'll discuss what is probability means, my dear students. In a given situation, what is the possibility of occurrence of an event? So occurrence of an event means what? Event means something should happen. It means sometimes we may talk like nammaneli ivattu event ittu, we have to do tomorrow that event, like that we will talk now. So event means that is nothing but something should happen. Clear? So what is event? Exactly what is event? What is experiment, random experiment, or what is this outcomes? That all will discuss later, my students. Just I am differentiating, means differentiating what we studied and what will we study next. That I am discussing, my students. So probability means what I told you, that is nothing but here it is, in a given situation what is the possibility of occurrence of an event. So what is the possibility? So you can observe, my dear students, what in which case means, if I have the coin and if I toss the coin means, so what is the possibility of getting a head, or what is the possibility of getting tail? We'll discuss this daily in life. We may see in many movies also. If they toss the coin, I think in Shivaji movie also we seen that. So if I toss the coin means, please make sure that you are tossing a coin, it should be biased. It means what it means biased? A biased coin means what? It means one side it should be tail and one side it should be head. Such a coin you should prefer, my dear students. Don't take, in some movies they'll show that both sides will be tail or both sides will be head. I think in Shivaji movie also that happens, is it? So don't take such type of coin. In this standard coin we should take. Standard means what? That the coin which contains both head, one side it is head and one side it is tail. So such a coin, if I toss the coin means the possibility, someone may ask, what is the probability of getting head? What is the probability of getting tail? Or else what are the, if I toss the twice a coin, what are the chances I am getting? The getting head of chances. What are the chances of the getting head? What are the chances of getting tail? That all we discussed. So that is nothing but that all we discuss in the probability. It means in a given situation, what is the possibility of getting that event or occurrence? That is nothing but occurrence of an event. That we are going to discuss. Clear? So my dear students, first of all I'll take one example. So what is example? A dice is thrown. Please remember, die is the singular form and dice is the plural form. So what is dice? You all know die is nothing but that is the one cube is there. On that we have the faces like 1 dot, 2 dot, 3 dot. One face it has 1 dot, another one place 2 dot, 3 dot, 4 dot, 5 dot, up to 6 dots it has. We will use to play the games. I think all of you observed that one, isn't it? Clear? And also, my dear students, in some movies In some movies you may seen that one. I think in Hollywood movies you may heard that casinos. So casinos means what? Where that is the place where we play so many games, isn't it? That mostly that useful, I mean that plays I think foreigners. In that you may seen that in Hollywood movies, isn't it? So clear. So that, my dear students, if you take the one dice, if you throw, what is the one dice is thrown, probability of getting 4. What are the chances of getting 4? To calculate such situation, we will using this as probability. This concept we are going to use. So in the 8th standard or in the 9th standard, in the earlier classes, we discussed such type of questions. So what is the example or what is the question I am discussing, my dear students? One dice is thrown, probability of getting 4. What are the chances of getting 4? So what are the chances, my dear students? So in that, what we will do, we'll just think in our mind how many we will throw the dice, means what are the possible outcomes, how many possible outcomes may come. Either we will get 1 or we will get 2 or we will get 3 or 4 or 5 or 6. These are the only possible outcomes. In that, the getting 4, how many, what are the possible cases there? We will get only once, isn't it? We cannot get more, no, we will get only once. Whether we may get 1 or we may get 2 or 3 or 4 or 5 or 6. 1, 2, 3, 4, 5, 6. Within this we will get. And in that, the getting 4 is only 1. Isn't it? So such cases, to calculate the probability of that event means in this case getting 4, or occurrences of getting 4, or chances of getting 4. To calculate such questions, to answer such questions, the scientists developed the theory, that is what we can call it as classical theory. This is fully classic, means old one. We know old is gold, like that this is very important theory here. It is that we can call it as classical theory. So how the classical theory is developed? By taking this example, as I told, total how many outcomes are there? 6 outcomes are there. In that, the getting of the exactly 4 getting is only one time. So therefore 1 by 6 chances are there. By this theory we develop, I mean the scientists developed the theory. So that is what we can call it as classical theory. So what is classical theory, my dear students? Before studying this classical theory, first of all we should know, to calculate probability of the any event, we have the three theories. The first one is called as, that is nothing but classical theory and statistical approach of the probability, and third one is axiomatic approach of the probability. Already we discussed this classical theory in the 9th standard, as well as we discussed statistical approach also, but we didn't discuss this axiomatic approach of probability. So my dear students, in today's class, I mean in the class 11th, we are going to discuss what is this axiomatic approach of probability. We all studied in the earlier classes, 8th, 9th, 10th, in all these standard you have this topic. In there, whatever we discussed, that all probability of the getting event, probability of calculating event is based on this classical theory as well as this statistical approach. So in class 11th, we are going to discuss this theory. Why this theory is developed means, by using this theory and this theory, means the classical theory and statistical theory have some limitations or restrictions. It means they have demerits. So to remove that demerits, what we discussed, what we studied, that another one theory is developed. That is what? Axiomatic approach of probability. Clear? So what is classical theory? Just I'll glance. We discussed already. Just I'll revise things, my dear students. So in the classical theory, what we will do? To get any event of the probability of the any event. So generally we can call it as probability of E. E is nothing but event. What is event? In detail I'll discuss next. But now probability of any event, if you take, means that can be calculated by using this formula. What is that one? Number of favorable outcomes divided by total number of equally probable outcomes. So equally probable outcomes means in experiment every outcome, I mean every, here it is, event should be outcome should be same. Every, if you consider any outcome, that probability, I mean the probability of the getting event should be same for all the possible outcomes. Clear? So that is what we can call it as equally probable. Clear? So my dear students, what is here it is, this theory, classical theory, what it says? It says that number of favorable outcomes whole divided by total number of probable outcomes. Clear? So in this, one die is thrown, the probability of getting 4, the probability of getting 4 is 1 by 6. How it is 1 by 6? By this theory. So how means the probability of getting here this, once if you one dice is thrown means here it is number of favorable outcomes. How many favorable outcomes? Favorable outcomes means what? Getting 4. How many possibilities are there? There is only one possibility, that I wrote here, this 1. And total number of equally probable outcomes. What are the possible outcomes are there? The possible outcomes are 6. So therefore 1 by 6, that is the probability of getting 4. So by this theory is classical theory. The classical theory says to get any probability of the any event, the formula is number of favorable outcomes whole divided by total number of equal probable outcomes. Clear? So my dear students, please remember this theory has the limitation, or the one demerit is there. What is that demerit means? Here we should take equally probably outcomes. So every time we shouldn't get the equally probable outcomes, isn't it? So that reason, in that cases or such situations, this theory fails. So because of this, another one theory developed to calculate probability of event, that is what statistical approach. Here it is, in the statistical approach, already we know, we studied the statistics. So statistics means what? Statistics means collecting the data and we will analyze that data and then we'll calculate, isn't it? So in the same way, in the probability also, what we will do, my dear students, here we will calculate the probability of the any event. We will calculate here by using the based on the observations and the collecting data. We will take the data and will take more number of observations. By taking that, by analyzing the observations and by taking the data, we can conclude or we can calculate the probability of the any event. So therefore we named it as the statistical approach. So my dear students, remember, in this case also, in this theory also, we have the limitation. I mean, we have the demerit. What is that demerit means? Here it is. This is applicable. This theory applicable only for the, here it is, we cannot finite outcomes it is possible. We cannot calculate for infinite outcomes, isn't it? So therefore, these two theories are fails, or there is a limitations or demerits are there. So that the another one scientist, he invented that new theory, that is nothing but axiomatic approach of probability. This theory was developed because of these two theory has the limitations or demerits it have. So what are those demerits? We cannot apply these two, here it is, we cannot apply these two theories for the infinite outcomes. Can't use with the infinite outcomes, as it is what our first note says. And what about the second one? The second number says that applicable only for equal probable outcomes. So only for the equal probable outcomes. The probability of getting each outcome is equally likely, means for each outcome the probability of getting it should be same. In that cases only we can apply these two theories. But there is some more situations comes. Where we may not have the finite outcomes or we may not have the equal probable outcomes. Then in such situations, what should we do? In such situations also, if I wanted to calculate the probability, means in that case we should go for the next theory, that is what axiomatic approach of probability. Clear? So till class 10th, I mean class 10th, up to class 10th, we study these two theories. Now our job is to understand the axiomatic approach of this probability. Clear? So this is all about what we studied in the earlier classes and what we are going to study in the next, in the class 11th, what we are going to study. Just I differentiated what we studied, what yet to study. Clear? So now we'll discuss this axiomatic approach of probability. So remember, my dear students, this axiomatic approach of probability is very important. But to understand this axiomatic probability, here it is, to understand this theory, we should know some terms, some definitions we should know. So what are those definitions, or what is that I'll discuss now. I think up to here you have a clear idea about this, all these concepts. So please pause the video, note down all these things, and next I'll discuss some more terms, or you can call it as the definitions. To understand this axiomatic approach of probability, we should know some definitions that I'm going to discuss. So please pause the video, that I'll discuss next. Concept, my students, we will discuss what is random experiment. Clear? As I told, to understand the axiomatic approach of the probability, we should know all these definitions or concepts we should know. So the first one is, my dear students, random experiment. So what is a random experiment means? Here it is, an experiment whose outcome cannot be predicted in advance certainly is called as random experiment. So what is random experiment means, my dear students? Another one definition of random experiment is an experiment in which two conditions should satisfy. What are those? The first condition is it should have more than one outcome, and we cannot predict the outcome in advance. Clear? So what is the example? First of all, I'll take the one example so that easily you can understand the definition of the random experiment. Say for example, if I toss the coin, so what is the possible outcomes you are getting? Either you will get head or you will get tail, isn't it? Yes. So is it possible to tell whether, if I toss the coin, is it possible to tell exactly you will get head or exactly you will get tail like this? Can we say? No, it's not possible. Is it clear? So my dear students, please remember, if I toss the coin, I cannot say that whether we will get head or tail, but we can say that we will get either in the head or tail, any one among that we will get. Clear? So such type of experiments we can call it as a random experiment. Clear? So what is the definition then? An experiment whose outcome cannot be predicted in advance certainly is called random experiment. Clear? And example, as I told, tossing a coin. You can take another one example, that is nothing but rolling a die. If you roll the die, you may get 1, 2, 3, 4, 5, 6. In these 6, you may get any one. We cannot predict, and it has more than one outcome. So therefore, that is also example for this random experiment. So what is next concept is, what is outcome? That already we studied in the 9th, 10th, but still just I am revising. So outcome means what? Outcome means by doing the experiment, we will get some results. So those results we can call it as outcome. So the definition is, a possible result of a random experiment is called as its outcome. We are discussing under the probability, that too in a random experiment we will discuss. So therefore, in this case, here it is, outcome means a possible result of a random experiment is called its outcome. Clear? So the outcomes, the examples, what is the outcomes? If I toss the coin, what are the results we are getting? If I toss the coin means either I'll get head. So if I toss the coin means either I'll get head or tail I'll get. or tail I'll get. So therefore these are the outcomes for this random experiment, tossing a coin. Clear? And the next concept is, my dear students, sample space. What is sample space? Sample space means the set of all possible outcomes of a random experiment is called as sample space. So what is sample space? It is the set of all possible outcomes of a random experiment is called as sample space. Say for example, if a coin is tossed once, then sample space is, and usually the sample space, it is usually denoted by the symbol S. So it is just collection of all possible outcomes. So as I told the example, if you toss the coin, either you will get head or tail. These are the only two possibilities, or else these are the two outcomes you are getting. Those two outcomes, if you write inside the set, that is what we can call sample space. So if you toss the coin once, then the sample space is S is equals, that is nothing but H comma T. H is nothing but head, tail is nothing, T is nothing but tail. In short, we will write H and comma T. Clear? So I think this is nothing but, my dear students, you can compare the sample space is nothing but, I mean, it is like as we studied in the first topic, it is nothing but the power set. What is power set? Have you remember that one? Power set means it is collection of all possible subsets. It is collection of all possible subsets, is it? So that we can call it as power set. Clear? So like that this is also clear. And next we'll discuss what is sample point. What is sample point? Sample point means it is nothing but each element of the sample space. In the sample space, whatever elements are there, that each element of the sample space we can call it as a sample point. Each element of the sample space is called as sample point. In this case, head, tail, these are all the sample points. Simple, my dear students, simple concepts are there. Only each element of the sample space we can call it as a sample point. Simply, instead of telling element, simply they gave the name that we can call it as the sample point. To look attractive, you may think, isn't it? So next, and the next concept is event. So what is event? Event means any subset, event is denoted by E. Any subset E of a sample space S is called an event. So my dear students, event is nothing but if any sample space if you consider, then here it is what they told, subset E of a sample space. So subset of this, so S is equals to H comma T. Here in this case H, you can take here this H, is it a subset of this sample space? And next take here it is another one T, it is also subset of this one. So H is also subset of this one, T is also subset of this one. It means any subset of the sample space we can call it as event E. So usually I'll name it as, here it is E1. This event I'll take it as E1 and this event I'll take it as E2. These are all the subsets of the sample space. So therefore these are the two events I can write. Clear? So I hope you understood. Still if you have any doubts, you can comment me, my dear students. I'll reply for that. In the next video, we are going to discuss the next concept, that is nothing but types of the events. What are the types of the events are there, that we are going to discuss in the next video. I hope you understood. Still if you have any doubts, you can comment me. As I told, I'll reply for that. Please pause the video to note it all this. We'll continue in the next video. Thank you.